To solve problem 3 easily, you need to know this fact here. I constructed this two adjacent triangles that share the same base. So essentially this point can move around here, and you got two triangles that are sharing the same base, as I said. And the vertex can move also, so you could have all kinds of weird shape. And this can move as well. So basically we got this flexible triangle that I can manipulate any way I like. But I want to bring your attention to these four pairs of four numbers here. Each one pair for each triangle. So here I got this area of this left side triangle. It's measuring real time. I didn't type these in. They are being calculated as I move them, as you can see here. Same thing about the length here. You see these numbers changing as I move them. You see. Okay, now this is what I want you to pay attention to. The area of a triangle, as you know, is the base times the height divided by 2. So in other words, area of a triangle is 1/2 base times height. And area of this triangle must be also 1/2 base times height. This base would be the base of the triangle, and this base is this space here for your computation. But I want you to realize here, when they share the same base like this, they will have the same height, because this is the height for both of them. So this height goes into both. So I want you to realize that when it comes to comparing the area of these two here, height will not have any effect, because they will have same number for both triangles at all times. No matter what I do to it, this number will be the same for both. That's what happens when two triangles share the same base. So no matter where I move the triangles, let me show you here. So if I say something radical like this and like that, then the height would be now from here to there. But this height, although now we went to the left side triangle here, is shared by both triangles. If you didn't see the left side triangle and all I gave you was the right side one, and say I gave you this problem and said, find the height of this triangle. Then you say, I got to extend this space and then draw a height and find it. Yes, that is the height. And you see, that is the height of the yellow triangle or the brown triangle. You see, so they share the same height. So what does that mean here? As I bring them here, I want you to realize that if I want to compare the area of these two, all I have to go by is the base. Once again, when you find the area is 1/2 base times height, right? Height is shared by both, so we are going to just ignore it. And you know what? Half is shared by both as well. So their ratio will be entirely dependent on the base and nothing else. To illustrate this concept, I will make the base to be the same number here. I will try my best to make them the same number. So I will move toward here. Here, I want you to see them. Don't look at my yellow circle. Look at these numbers here and see if they become the same. That's as close as it gets, right? And then you can look at it. 22.74, 22.73. Huh. So they indeed are the same when these two becomes the same. Now to make it more difficult, let me move the height. Okay, base didn't change, only the height changed. But look at their areas. Their areas are the same. Now if I move the height over there, areas are the same. If I move height over here, the areas are the same. So don't be fooled by the shape of the triangle and where they go and how they're drawn. If they are created by the same base like that, the easiest way to think of is if two triangles were created by drawing one and then slicing like this. That's the case. You have this common base. Then their ratio of their areas will be a ratio of their sides, their bases. So now let me try my best to make this one side twice as big. So let's see if I make this side twice as big as the other one. That would require some thinking. Did I get it? Yeah, 4.4, 8.8. So this is roughly twice of this, right? And then you realize 23 is twice of 11.5. So now, no matter where I move this here, left side will be twice of the right side. If I go like that, yes, numbers are dancing all over. 30 versus 15. So whenever a triangle is drawn in this fashion here, I want you to realize that when to find the area, the ratio of the areas, don't even think about finding the areas. Just find the length of the bases, and that ratio will tell you the entire thing. So here, in this case, I don't even have to tell you how long these are. So for example, let me just delete them. That's how radical I am. And I will just tell you the ratio is 2 to 1. I didn't even tell you how long it is. Then the entire triangle is, say, 15. Okay, area is 15. Then what's the area of this one to this? Well, got to be 2 to 1 ratio, so it's 10 and 5. Just like that. Okay? You may say, it's not 10 and 5. Well, I'm saying the ratio. If I said the total was 15. The way it is, total is not 15. I can force it to be. Let me show you. If I make it 10 here. And then you see it's 5. No, I wonder if I can really bring it. Yeah, this is as close as to 10, right? And this is very close to 5. Just like that. So that's the basic that you need to know to solve this problem.